In this section, we're going to evaluate 4 different light bulbs: a halogen, an incandescent, a CFL, and an LED. And we're going to compare these light bulbs' energy use and cost to run using this watt meter. The halogen and incandescent bulb are based on Edison's original design with the incandescent filament in it. That filament generates a lot of heat and wastes a lot of energy. The CFL and the LED are based on newer technologies, which make them run cool and use energy far more efficiently. So we're going to start with the halogen. It's rated at 47 watts at 490 lumens. But let's see what it meters at. The watt meter reads about 47 watts. That means that if we take this light bulb and run it for 4 hours a day, 7 days a week, for 365 days, it'll cost us about $6.80 at 10 cents per kilowatt hour. Next, we're going to test our incandescent. It's also a 45 watt bulb, but is only 330 lumens. So let's see what it meters. Looks like it's showing about 46 watts. That means if we run this light bulb for 4 hours a day, 365 days a year, for that same 10 cents per kilowatt hour, it costs about $6.75 a year. Let's take a look at the CFL. It's a 14 watt bulb rated at 900 lumens. But let's see what it meters at. Our meter is showing about 14.5 watts. That means that if we run this bulb for the same amount of time as the others, it'll cost us about $2.15 to run. Last, we'll take a look at the LED, which is rated at 7.5 watts and 430 lumens. Looking at the meter, looks like we have about 8 watts, which means this light bulb will cost us $1.10 to run 4 hours a day. You've heard all the hype that CFLs and LEDs save energy. Now you've seen it for yourself. A CFL costs 1/3 what an incandescent costs to run, and an LED costs half what a CFL costs to run. Customers will say, "Oh yeah, I know that a CFL will save me money. I replace my incandescents every time they burn out with a CFL." But they don't realize that if that incandescent lasts a year, they spend 3 times as much money as they would spend if they replaced it with a CFL right now. And if you multiply those savings across all the light fixtures in a homeowner's house, it adds up to big savings in energy, money, and ultimately the conservation of natural resources. In this section, we're going to evaluate 3 cooling appliances: a fan, an evaporative cooler, and a window air conditioner. We're going to compare their energy usage and their relative efficiencies by looking at how much energy they use, the temperature of the air coming into the appliance and going out of the appliance, and then we're going to calculate how many watts each device uses to lower the temperature of the air 1 degree. So now let's evaluate our fan. The thermometer says that our ambient temperature is 73.1. So we'll insert our thermometer into the fan, turn the fan on, and while the air blows across the thermometer, let's take a look at what our watt meter says. It shows 21.2 watts. Our thermometer is showing about 72.4 degrees. So with our fan, we're using about 21 watts to get 1 degree of temperature drop. Now that makes sense because a fan doesn't change the temperature of the air. It simply moves it around. So we'll talk a little bit more about that when we do our analysis of all of our devices. Let's take a look at our evaporative cooler. This appliance has been running for a while, so it's at steady state, and that'll give us the most accurate temperature reading and wattage reading. Looks like we have 59 watts on the meter and 63 degrees on the thermometer. That's 10 degrees of temperature drop, which means that we're using about 6 watts for every degree of temperature drop. Now, we're using more energy than our fan, but we're getting cooler air coming out of our device. How does that compare to our window air conditioner? Let's take a look. Evaporative coolers work great in arid climates, but where the humidity's high, we have to have air conditioning. But there's a price to be paid, and that price is high electric usage. On this window air conditioning unit, we're seeing almost 30 degrees of temperature drop. But our watt meter is telling us we're using over 450 watts to get that. That's more than 7 times what the evaporative cooler used and 3 times more per degree of temperature drop than the evaporative cooler. But if you live someplace humid, really, you don't have a lot of options beside the fan and the air conditioner. Let's go back and talk about the fan. Even though it doesn't change the temperature of the air, it still has the ability to keep a building occupant comfortable. And because it uses the least amount of energy, it makes it the most efficient option. The same is true of ceiling fans. What about whole house fans? Well, whole house fans work by exhausting warm air out of the house and drawing cooler air into the house. So they work the best in the early morning and the late evening when the air outside is cool. So comparing these cooling appliances, the fan is the most efficient because it uses the least amount of energy, even though it doesn't change the temperature of the air. The evaporative cooler is the next most efficient appliance because it uses the least amount of energy per degree of temperature drop. But it only works well in arid climates. Last is the air conditioner. It uses the most energy and it uses the most energy per degree of temperature drop. But in humid climates, it's the best option because it works and it works well to keep building occupants cool.